All right, in today's lesson, we're going to find all the real roots of polynomials. So here's the game plan, all right? We're going to type the equation into your y equals, and so when you do that, you want to make sure you use a little caret to put the exponents up here, and then make sure you get out of the exponent before you write the rest of it. It gets really annoying if you type all this up in exponent. We can try this in class if you're having issues, but we're going to type this in our y equals. We're going to look at our graph to find the roots, because remember, roots are just the x-intercepts. Where is it crossing the x-axis? And then we're going to prove that they're roots with synthetic division. Now, how do we know if they're roots? Well, because there will be a remainder of 0 or no remainder. That's how we prove it. So today you're going to graph, and we're going to use what we see in our graph to help us do synthetic division. So if I look at my graph here, I can see that it crosses over here at -3. So that means one of the roots is -3. So I'm going to do what I did before, drop the x's and put everything in exponent order. So I'm going to do 1, -2, -11, and then 12. And then let's do synthetic. So drop the 1. 1 times -3 is -3. Get -5. -5 times -3 is positive 15. That gives me a 4. 4 times -3 is -12. And it's 0. It should be 0, okay? Then look for, and normally this is where we would write our equation, right? But now we're just going to stack the next step. So we did this 0 right here. Look at this one. This is at positive 1. So I'm going to put a 1 here now. Do the same thing. Drop this 1 down. 1 times 1 is 1. -4 times 1 is -4. Now we have 0. Again, no remainder. That's what we wanted. Now, remember our degrees. This was the third degree level. This is the second degree level. And then this is going to be the first degree, or the linear level. All right, so let's just keep on trucking. Now let's look back at our graph. Look at where the next root is. We used this one. We've used, let me try a different color. We did this one. We did 1, 1, 2, 3, 4. So where x is 4, now we're going to use that as our last root and prove that it works. So let's divide by 4. 1 times 4 is 4. -4 and 4 is 0. And that's it. So now that all these were zeros, we have proven that these are all roots. So I write my answers as -3, 1, and 4. This is the work you got to show. I know you're getting the roots from the graph, but you got to show me this synthetic division. Let's try the next one. All right, so the next one is 4x to the 4th minus 18x squared plus 81. Now I put this in my y equals, and I've looked at my graph. Now let's stop and think about this. This is the 4th degree. That means there should be 4 solutions, right? Well, but look at the graph. It only touches the x-axis 2 places, but if you notice, they're bouncing. So these are double roots, so we need to pay attention to them and use them twice as we do synthetic. So this one is at, what, -3, and this one's at +3. So let's start with the -3, and let's put our exponents in exponent order. Now notice I need a placeholder for x to the 3rd, so I'm going to do a 1 for x to the 4th, 0 for x to the 3rd, -18. Notice I don't have just an x term in here. I need that 0x in there, so I need to put a 0 here and an 81. So here's a little trick for you. Notice the power, the degree of your polynomial is 4. That means I need to have one more coefficient here. So if I have 4, I should have 5. 1, 2, 3, 4, 5. Like on number 1, there's a power of 3. That means I should have 4 coefficients. So that way you know you have everything accounted for before you do all the work and then get annoyed that you forgot a 0. So anyway, back to the question. So let's bring down that 1. 1 times -3 is -3. 0 plus -3 is -3. 3 times 3 is going to be a 9. This will give me -9. -9 times -3 is a positive 27. Add those, I get 27. 27 times 3 is 81, and it'll be negative. Oop, that's a 1. And a remainder of 0. So that checked out. Great. Now, it's a double root, so I have to use it twice. So I'm going to use that -3 again. Let's see what happens. Bring that one down. 1 times -3, -3. -3 is -6. 6 times 3 is going to be 18. Negative 9 plus 18 is positive 9. 9 times negative 3 is negative 27, and I have a 0 remainder. Bingo. Now we're going to move to the other root, the positive 3. Bring it down. 1 times 3 is 3. Negative 6 plus 3 is negative 3. Negative 3 times 3 is negative 9, and I get 0. So this one worked out as well. Again, this is a double root, so I have to use it twice. And here we go. 1 times 3 is 3. Negative 3 plus 3 is 0. That worked out, and so we've all checked out. So our solutions are negative 3 as a double, and we have 3 as a double. So remember, you have to notate it if it's a double so that we are accounting for all 4 roots. All right, let's look at number 3. F of x equals x to the 4th minus 6x to the 3rd plus 54x minus 81. So I put this in my calculator and I've looked at my graph, and I want you to notice where are the x-intercepts. So I'm going to zoom in for a second so we can write on this. Now notice, where is it crossing? It's cutting through nicely right here where x is negative 3. That just looks like it's a single root. But this one over here on the right, it's going through at 3, right? But notice how it's flattening. So that means it's a triple root. So we're going to have to use it 3 times. And that will account for all 4 roots. So let's get after this. Let's do this. So if I use my first root of negative 3, look at my coefficients, make sure we have everything accounted for. X to the 4th would be a 1, then a negative 6. I don't have an x squared, so I need to put that placeholder in, 0. X to the 1st, and then minus 81. Remember, it's to the 4th power, so I should have 5 numbers here, and I do. All right, let's do this. So bring the 1 down. 1 times negative 3 is negative 3. Add these, negative 9. Negative 9 times negative 3 is a positive 27. That's 27. 27 times 3 is 81, be negative 81. If I subtract those using my calculator, I get negative 27. Negative 27 times 3 is 81. It's negative times a negative, so it's positive, and there's 0 remainder. That checked out. Now we're going to go over and use the positive 3 root. We got to use it 3 times, right? Let's do it the first time. So bring the 1 down. 1 times 3 is 3. Negative 6 times 3 is negative 18. 27 minus 18 is a positive 9. 9 times 3 is 27. And that is 0 remainder. Let's do it again. Use that positive 3 one more time. 1 times 3 is 3. Negative 3 times 3 is negative 9. Again, 0 remainder. So I've got 1, 2, I've got to do it that last time. Remember, we were at the 4th degree, 3rd degree, 2nd degree, 1st degree. We're going to get all the way down and finish this off. So 1 times 3 is 3, and 0 remainder, and it checks out. So my answers are a negative 3 and a positive 3 is the triple. Now, I know you can get these from the graph, but again, your work is your answer. All right, you've got to show me the synthetic division that it all comes out zeros. All right, let's try the last one. All right, number 4, f of x equals x cubed plus 11x squared plus 30x. So if I put this in my calculator, this is what it looks like. All right, let's look at this for a moment. Let's find those roots. All right, so this one is at 1, 2, 3, 4, 5, 6. This is negative 6. That means this one is a negative 5. Notice they're just cutting through the x-axis, so they're single roots. And this one is at 0. That's a single root. That should make sense because if I look at my equation, it's the 3rd degree, so that I know it's going to have 3 solutions. So there they are, negative 6, negative 5, and 0. So let's get after this. Let's do this. Negative 6, let's put our coefficients in. 1, 11, 30. Now, remember what I said? If it's to the 3rd power, I need 4 things. That means I need that constant 0 out here. So let me say that one more time. Remember, whatever the degree is right here, you add 1, and that's how many numbers you should have when you do your synthetic. So you may need zeros for placeholders. In this case, they went in exponent order to the 3rd power, 2nd power, 1st power. Then that means I need the 0 on the back side. All right? Now from here, we just do our synthetic. 1. 1 times negative 6 is negative 6. 11 minus 6 is 5. 5 times negative 6 is negative 30, and I get 0. 0 times negative 6 is 0, and I have a remainder of 0. That worked out well. Now let's go and do the next root of negative 5. Bring that down. 1. 1 times negative 5 is negative 5. 5 minus 5 is 0. 0 times negative 5 is 0. This one worked out. We're good. Last one is at 0. Should make sense. 1 times 0 is 0, and then 0 root. So we're good. So our answers are negative 6, negative 5, and 0. The reason I did this example is to remind you, sometimes you need that 0 on the back side, okay? You always want to make sure you have 4 coefficients if it's a third power, and so on and so forth. All right, good luck, and we will see you in class.